guys, today we're gonna continue solving systems of linear equations, but this time around we're gonna solve systems by substitution. Overall, we're gonna do 3 problems using this technique, or maybe 2, I forget, but we're gonna spread it 1 problem per video. So let's do this. So it says use the substitution method to solve the system of equations. For those of you that are big fans to solve systems by graphing, that's not going to cut it because we are asked to use this technique or else. So substitution, how does that work? So pretty much you have to pick an equation and solve for one of the variables. Let me go ahead number these. So 1 and 2. So pick an equation and then solve for a variable. Ideally, it would be nice if we had a variable whose coefficient was 1 or -1. But as you can see, none of these variable terms have a coefficient of 1 or -1. So what we're going to do, we're going to go ahead, look at all these terms and see if we have a good candidate. I'll expand on that in a bit. So if we were to solve for x in the top equation, we will eventually have to divide both sides by 8. 8 does not go into 2 and 10, so we're gonna have fractions. We don't have time for that, so not a good choice. What if we solve for y in the first equation? Well, if we do that, we're eventually gonna have to divide both sides by 2. Lucky for us, 2 goes into 8 and 10 a clean number of times, so we're not gonna have fractions. So that will be a good candidate or a good choice to solve for. Okay, now let's go. We already have one good option, but let's see if we have others to pick from. If we solve for x in the bottom equation, we will eventually have to divide both sides by 2. 2 does not go into 3 and 12, so you will have fractions. And I'm trying to avoid them like the plague. Alright, what if we solve for this y? If we solve for the bottom y, we'll eventually have to divide both sides by 3. And same speech, 3 doesn't go into 2 and 13 a clean number of times, so we're going to have fractions in the expression. So my recommendation is to solve for this guy, okay, 2y. So the rule says pick an equation and then solve for a variable. So I'm going to speak to myself. So I'm going to say, let's go ahead, look at the first equation. So we're going to say, look at the first equation and solve for y. And the question is, Ms. Torres, do we really have to write? Oh, I've discovered my identity. Scratch that. Okay, cool. So the question is, do we really have to write love notes to ourselves? No, but you know what? When it comes to taking notes, you can never write too many notes. It's the other way around. It's how come I didn't write more notes? So our love note says, let's look at the first equation and solve for y. So let's go ahead and do that. We're going to take our first equation and solve for y. So to isolate the y term, let's go ahead, subtract 8x from both sides. And for the grand finale, to get rid of the times 2, let's go ahead, divide both sides by 2. And that will leave us with y equals -4x plus 5. And I'm going to go ahead, highlight this. So substitution, how does that work? So substitution says pick an equation, any equation, and then solve for a variable. We just did. And then when substitution said step 2, then substitute this expression into the other equation you didn't use. So we're going to substitute the expression of -4x plus 5 for the variable y into the other equation we didn't use, which is the equation number 2. So we're going to say sub into 2. So we're going to substitute this expression into the other equation we didn't use. That's what I get for crossing my T's, dotting my I's, whatever that saying goes in English. Alright, so equation 2 reads 2x minus 3y is equal to 13. And we are going to substitute the expression of -4x plus 5 wherever we see the variable y. So in this case, it will be right here. So we have 2x minus 3 times the expression for y. According to our hard work, that gives us -4x plus 5. Fantastic. So at this point, we are going to focus our energy on this new equation and solve for whatever variable we see. In this case, is x. So take your time, watch your negatives. When we distribute the -3, that will give us 12x minus 15 equals 13. Let's go ahead, combine the like terms. When we do, the sum of 2x and 12x will give us 14x. Work your magic to isolate the variable term. To undo the subtraction by 15, let's go ahead, add 15 to both sides, and that will give us 14x equals 28. So for the grand finale, let's go ahead, divide both sides by 14, and that will give us 2. So substitution, how does that work? So we're going to pick an equation and solve for a variable. Then we're going to substitute this expression into the other equation we didn't use, which is 2, and then just solve whatever you have. And then for the almost grand finale, now that we know what x is, we need to know what the value of y is. So let me speak to myself. So I'm going to say find y. Okay, so how are we going to find y? We're going to substitute a 2 for x into any equation of our liking that has the variable y. It could be the original equations, it could be the one of the revised equations, but the really nice thing about substitution is that you will always have an equation that solves for that second variable that you need. So let's go ahead and use this equation right here. Y equals negative 4x plus 5. For me, whenever I'm going to substitute a number for a variable, I like to put a semicolon. So that will leave us with y equals negative 4 times x. In this case, it's 2 plus 5. If my arithmetic doesn't fail me, product of negative 4 and 2 will give us negative 8. And that sum should give us negative 3. So if you can find the x and you can find a y, then the system has a solution. Okay, remember, the solution to a system is the ordered pair or ordered pairs that is a solution or solutions of all the equations in the system. So if x is 2 and y is negative 3, then the solution is given by the ordered pair of 2, negative 3. Don't forget to wrap it up, because if you don't put parentheses, this is not an ordered pair. It's just a list of numbers like a grocery list. But you put parentheses, bam, that's an ordered pair. Thanks guys, we got 2 more to go.